Hello, and welcome to our program, Astronomy for Everyone. The topic for this month's program is the Arecibo Radio Telescope. And here to tell us all about it and her experiences there is our guest, Paulette Epstein from the Michigan Science Center. Paulette, welcome back to the show. It's been a while.
It has been a while. Thanks for having me, Don.
You're welcome. You're welcome as always. Now, what are you doing these days at the Science Center?
So I am the Director of Science and Theaters at the Michigan Science Center. I'm, of course, the staff astronomer as well, which is the hat that I wear most often.
And you're also a solar system ambassador, I think?
I am, yes. I am a volunteer for NASA's JPL, and I am a solar system ambassador.
Terrific, terrific. So you wear a number of hats.
Lots of hats, yes.
Well, what we want to talk about today is your time at the Arecibo. And so where do you want to start?
Absolutely. So the Arecibo telescope is located in Arecibo, Puerto Rico, and it is a radio telescope. So it is actually located in the top of a mountain, in a crater in the top of a mountain, and it's about 50. It's a 50-foot dish, and it does radio. We do radio astronomy with that, and it's a fantastic place to visit. I was there about 10 years ago at this point, actually.
Okay. How long of a time did you spend there?
I was there for about a week and a half in January, of course. So this was my my college trip in January, my senior year. So it was so nice to get away from that snow. I went to University of Wisconsin-Stevens Point. So
yeah, lots of snow.
Lots of snow.
Lots of snow. Okay. So you mentioned it's a radio telescope. Mm-hmm. I've always wondered, could they steer it, or is it just sit stationary? Or
you know, that's a really good question. So they can't steer it. The radio telescope, the dish itself, actually sits inside of the crater. The thing that moves is the thing that's up top. So when you look at it from the top down, you're actually able to see the dish underneath, as well as the detectors up top. And the detectors move back and forth along a line that's up there. So they can actually move around, but the detector, the dish itself stays put. Also, for our research, we relied on the fact that the Earth also moves. So technically the dish is moving as we rotate on our axis. And that's how we were able to do an all-sky survey, or most of the sky survey was actually just waiting for the Earth to rotate on its axis, as well as for it to orbit around the sun.
Okay, so it is a movable, in the grand scheme.
Technically, yes. Yeah. Especially for our research, we relied on that a lot.
Okay. Did you find that you had a limiting horizon, even with all of the rotating and the?
We definitely did. We had a smaller area of the sky that we were able to look at. So the project that I worked on was called the Alfalfa Project, and I was there sort of looking at the data and confirming things that they had seen in years past. So I was there as an undergraduate, and I was there with the Alfalfa team, which is out of Cornell. And so we were looking at certain areas of the sky, but we were only able to see where the dish allowed us to see. And what we were looking for is we were looking for something called hydrogen alpha. So hydrogen alpha is cold hydrogen. Hydrogen alpha is where the hydrogen atom flips its spin. And this happens every once in a while. And so that's something that we could actually detect in the radio part of the spectrum. So with that hydrogen alpha, we were looking for that flipped spin and the light or radio waves that were emitted from that. With that, we were looking for cold galaxies, so galaxies that were made just out of hydrogen and hadn't formed any stars yet. So it was a really interesting research topic for us because it's something that I had done a lot of optical astronomy. So I went to Kitt Peak National Observatory and did research there. Mm-hmm. But the radio side of things was really weird because what we were excited about wasn't an image. We were excited about a spike in data. So we looked at that area of the sky, saw that spike in data, and we're like, yay, we detected this cold galaxy, the galaxies that haven't formed stars yet. But it was really, really interesting because at an optical observatory, you have to have all the lights off, and you have to have, like, when you go outside at Kipling National Observatory, we had to drive down the mountain without lights because we weren't allowed to have them on if we drove at night.
It doesn't sound real safe.
It isn't, but you don't want to shine somebody in the telescope if
That's true.
they're trying to get data. Well, with radio astronomy, you don't have to worry about that. Radio astronomy, it's not detecting visible light, it's only detecting the radio part of the spectrum. So what you really had to worry about was cell phones. They didn't have Wi-Fi up on the top of the mountain. You could only use wired internet. This was 10 years ago, so Wi-Fi wasn't quite as big as it is now.
Sure.
But it was very strange to be up at the top of a mountain like that. So there is an image of me in front of the telescope. It was a really cool experience for me to have. And looking directly at the center part of it, that is where the detector is located. So in that detector area houses the detector that we were using as well as some others. There's also a line that comes down because the dish is actually spherical, whereas optical dishes are not spherical. And we actually ran into an issue with that when we launched the Hubble Space Telescope. They created a spherical mirror with the Hubble Space Telescope. For the first 2 or 3 years of the Hubble Space Telescope being up there, it was sending us blurry pictures. Mirrors in...
Wasn't that because they misground the mirror? That was what I had heard.
Yeah, they misground the mirror, but mirrors should be hyperbolic or parabolic.
Okay.
They should be parabolic, and they ground it to spherical. So in radio astronomy, they can actually be, there isn't a single point that you're trying to detect. There's usually you have those antenna when you're trying to detect radio waves, because you actually need the vibration to go through the whole antenna. And So they actually have it so that it goes to a line instead of a single point like the optical telescopes.
Okay.
So the dish itself is actually spherical instead of the parabolic that we would see with the visible ones, which I think is fascinating. So if you've ever seen the James Bond movie, which one was it? We actually watched it on the mountain. GoldenEye, that's what it is. When they drain the lake at the end of it, that's actually the Arecibo telescope. And when they're fighting out on that line, they're fighting out on the radio detector.
Oh my.
So we actually watched, during our research out there, we watched GoldenEye, and we also watched Contact, because that's also filmed at Arecibo, or at least
that's
parts
right.
of it are.
Yeah.
Mm-hmm. So with our research, we were able to actually go out to the detector itself. So when we were looking out towards the detector, there's this big long catwalk to get out there because it's a 50-foot dish. So you have to walk quite a ways to get out there. So we walked along that line, and looking back, you can actually sort of see how far that really is. It's crazy.
It doesn't sound that far when you say it, but I'm sure it's...
It feels that far when you're looking directly down. But we did go out there, and when you look directly down, our friends that were out there, so we had 2 groups of students that were out there that we split into 2, and some of the students went under the dish, and the other set of students stayed on the dish, and we were looking down, and we're like, they look like ants down there.
Wow.
So it was pretty crazy. But when we actually went into that globe that's there, we were able to see the detector itself. And so the detector itself has...
Was that big? You could walk into it?
You could walk right on into it, yeah.
Because I've seen pictures of it, and you think, well, it's this little basketball-sized thing.
Oh, no. You walk right into it. You did have... some of my colleagues had to duck down a little bit. I did not. I just mosey right through there, but I'm also a fairly short person. But it was very crazy to see the detector itself and all of the different sort of receivers that are in there, and where they actually detect the radio waves for the Alpha project, the Alpha project.
Great. It's a fascinating place, and we're going to pick up more of this in the second segment, but we got to take a break right now.
All right.
Yeah. So if you would have a question and you would like to send us an email, as always, we put the email address down at the bottom of your screen. And coming up next is Stephen with Term of the Month.
Thanks, Don. The term of the month is Kama O'Aleva. Kama O'Aleva is Earth's second moon. It's 40 to 100 meters across. It has an Earth-like orbit and lunar-like silicates, and it may be a bit of the moon that has been broken off. It was first seen on April 27, 2016 by Pan-STARRS on Haleakala, Hawaii. The name Kama O'Aleva is derived from the Hawaiian words ka, meaning the, mo'o, meaning fragment, and leva, meaning to oscillate, which is what the orbit does on the sky. It sometimes orbits inside the Earth's orbit and sometimes outside. Current orbits are 366 days, but the average is closer to 365. The orbit is inclined 8 degrees with respect to the ecliptic, so it bobs up and down annually. It can get as close as 38 times the distance of the Earth to the Moon. This gives the object the classification of a quasi-satellite of the Earth. Asteroid 2003 YN107 had a similar orbit over 10 years ago, but has since left. It is Kama O'Aleva is expected to stay with us for about 300 years. It is a fast rotator, less than a half an hour for each rotation. And that's Term of the Month, Kama O'Aleva. Back to you, Don.
Welcome back. We're here with Paulette Epstein from the Michigan Science Center, and we're talking about the Arecibo Radio Telescope. So Paulette, we were talking about above the dish just before the break. So is there anything else that we want to talk about up there before we head down below?
Oh, so yeah, we focused on the detector and all the stuff that you can see up top, and now we're going to actually go under the dish. So like I said, we split into two, and we had half the folks go up, the other half go down, and then we swapped places. So the radio dish is actually really cool because it is not solid. It's a mesh material. It is actually, there's lots of holes in it. So underneath the dish is a green space. There's a creek that runs through it, and there's lots and lots of greenery there. So the really cool thing about radio is that you don't need, like with optical, you need a solid mirror.
Right.
Where radio waves, as long as you're catching the radio waves, which are really long, it doesn't need to be solid, because they would actually have an issue with it because it's basically pointing straight up. They would have an issue with water pooling on top of that if it were solid.
Exactly, because it does rain in Puerto Rico.
Yes, it rains a lot in Puerto Rico. Actually, it rained about 50% of the time that we were there, but the great thing about radio astronomy is that it doesn't matter if your skies are clear, because those radio waves are going to get through those clouds anyhow. So we were... when it did rain, there were these little tiny frogs. They were called coqui frogs, and they made this like coqui, coqui, coqui sound.
Okay.
And they were going basically the whole time that we were there too. So underneath the dish, like I said, it has that sort of green space. And if you look from sort of the eye level of the dish, we also have an image of that, where you can see like there is stuff on top of it. It's really dirty. It's actually kind of gross. But
Really?
yeah, because there's all sorts of LICA and all sorts of other things growing on the dish itself. But again, with radio astronomy, it's not, you don't have to have a perfectly ground mirror. So radio astronomy was really cool, and seeing Arecibo was really cool in that space, because we were actually able to see like stuff growing out of the dish itself. So like, because the mesh was wide enough, stuff was actually growing up through the mesh itself, but it didn't affect our data at all because of the types of waves that we were trying to find.
Okay.
Yeah, so radio astronomy is really, really fascinating, and I was very happy that I was able to go to Arecibo and do this research. Like I said, this was about 10 years ago at this point, so 2012, and a lot has happened since 2012.
That's what I hear.
Yes. Yeah. Yep. So unfortunately, in 2020, one of the big pillars, the wire snapped and the pillar collapsed. And when it did that, it actually collapsed on the dish itself. And in this image, you can see a lot of the damage from that.
Oh my.
Unfortunately, it broke apart a lot of that dish, and it is probably at this point unrepairable. So if we look at it from the top down, you'll actually be able to see exactly how much damage was done to that.
That's quite extensive.
It is very extensive. We actually, on our trip, walked around each of those pillars and walked around the entire dish itself. So it's kind of weird to see these images of it, because I was there, like right next to that. And now, unfortunately, it's ripped a hole right through the center of that. And so the plans for the radio telescope itself, for the Arecibo telescope, are actually not to rebuild it, because it is just one telescope. So for radio astronomy, it's actually a lot better if you have multiple radio dishes, like in the large array or the very large array.
Sure.
So that you have a larger area that you're actually detecting. A single radio dish can only do so much.
Well, when was Arecibo built? Do you know?
I'm actually not sure of that one. It was built quite a while ago, though.
That was the idea, you build one huge dish versus now where they're using the mobile dishes on tracks. And
Yep, and so and the nice thing about the mobile dishes on tracks is you can aim those.
yes, you can.
You kind of have to hope that whatever you're trying, well, not hope, you have to calculate whether or not the thing you're trying to view is actually going to come into view if you're at the Arecibo telescope. So unfortunately, like I said, they're more banking on some of those other large arrays with radio dishes. And so Arecibo itself, at this point, there aren't any plans to reopen it.
Okay.
Although they still do some radio astronomy up there. They have some telescopes up there as well. They have some other radio dishes up there. And so it's still actively being used, that area, but the dish itself is unfortunately just hanging out there.
Yeah, I have to ask a question. Didn't the powers that be note that some of this was starting to degrade to the point, or?
They did.
Okay.
They started to see some issues with the pillars and with the wires that were holding it up. They didn't quite get how extensive the damage was. So in 2020, there was just a giant storm that ripped through, and that's really what did the most damage, was the hurricane that ran through it. And so the damage that they did see from it just got multiplied when they had that storm roll through. So unfortunately, there wasn't enough time between when they started to notice the issues and when they were able to get funding and actually fix the issues, because funding is also a huge problem in astronomy.
I was going to ask.
So I was really lucky. Going to school at the University of Wisconsin-Stevens Point, we had a bunch of different opportunities for research around. That's why I went to Kitt Peak National Observatory. That's why I went to Arecibo, because we actually had time at those radio telescopes and we had funding available. But I'm finding out a little bit more now that funding is much, much harder to come by than I had thought in college.
Oh, okay. Just the money appeared, and it's not how it works.
that is definitely not how it works. So now I do a lot more grant writing and stuff like that, so I understand where all of that is coming from. But yeah, unfortunately, the funding to fix the radio telescope isn't there, and the damage is so extensive. And there's better technology out there now.
I was going to say,
Yeah.
The thing is, what, probably at least 50 years old?
Mm-hmm. Yes, yeah.
And has, technology kind of passed it by in a sense?
It definitely has.
Yeah.
So Arecibo was part of a way to get a radio telescope that was the size of the Earth. So you can have, as long as you have the radio telescope stationed all pointing at the same object at the same time, certain distances away, you can actually simulate a radio dish the size of the Earth.
Uh-huh.
And Arecibo was one of those locations that could be used for that. So at this point, it's no longer a location that could be used for that, but we could put radio antenna all over the Earth and then make a radio dish the size of the Earth,
Yeah.
and actually be able to see further back and to gather more data than we were before. So now that we have these computers that can talk to each other across the globe instantaneously, there's really nothing stopping us, other than, of course, funding and building dishes, from being able to do that. Where when Arecibo was built, they didn't have that you could talk across the planet so quickly.
Yeah. Technology, since that was built, has, leaps and bounds as to what we can do.
Absolutely.
And even wireless, like you say, 10 years ago, up there in the mountaintop.
Well, and they couldn't have wireless internet because that is a radio wave, and so it was interference. They actually they were detecting something at Arecibo at a certain wavelength, and they couldn't figure out what it was, and it was the airport. It was the airport at San Juan.
Okay.
Like they were picking up the radio waves from that, and it was outside of our part of the spectrum that we were looking at. Luckily, but anything that they were trying to do with that part of the spectrum, they can't see anymore because of all the radio waves that are interfering.
Oh boy, sounds like a problem. But it sounds like we've got a lot of other opportunities, even without having the Arecibo dish out there.
Yes,
so,
absolutely. Lots of other opportunities, and luckily the opportunities that we have in the future are even better than Arecibo. Now, I will say it was beautiful. And it was great to be there, and it was great to be in Puerto Rico, especially in a Wisconsin January. But it was an amazing experience because it is a fantastic piece of technology. But for furthering research, there are definitely better options out there.
Well, that's encouraging that things are looking up in spite of the loss of the Arecibo. I would like to thank my guest, Paulette Epstein from the Michigan Science Center, for stopping by today to fill us in on this extraordinary facility that was. And we would like to have you visit our website. The address is down at the bottom of your screen. And to round out the show, as we always do, here's Stephen with What's Up.
Thanks, Don. What's up in the night sky for March 2022? Now, on March 20th, we have the spring equinox in the north and the autumnal equinox south of the equator. So that's March 20th. It's not exactly equal night and day, but it's pretty close. Now, the month starts on the 2nd. With a new moon. First quarter is on the 10th. Full moon is on the 18th. Now remember, the full moon is when NASA couldn't go back to the moon. It was fall. And then the third quarter is on the 25th. April starts with a new moon right on the 1st, so April Fool's Day. Now, in the morning sky, we have a bunch of planets. Saturn, which is extremely close to the Sun. You may not be able to spot it, but Saturn is in Capricornus. Mercury moves from Capricornus to Cetus over the course of the month. Pluto is still not a very good time for Pluto, but at the end of the month, it is late enough, it does rise early enough that you can be fairly far from the Sun and possibly get your telescope pointed. But we also have Mars in Sagittarius moving to Capricornus over the month, and Venus going from Sagittarius to Capricornus over the month. Now, Venus has max western elongation on the 20th of March, so that is as far away from the Sun as it gets. That might be a decent time to spot Venus in the morning. Now, the evening sky only has one planet, and here shown also on the 1st of March at 9 p.m. local time, roughly speaking, is Uranus. It's fairly high in the sky. The sky is fairly dark. You'll need at least binoculars to see Uranus, and it's worth a look. Now, Jupiter and Neptune both have superior conjunction. Jupiter on the 5th and Neptune on the 13th. Now, in this looking down from the north at the solar system, with the Sun in the center, actually in the blow-up on the left, you find that Earth is to the left and maybe just a little above the Sun, if you will. And in the big picture, you have Jupiter and Neptune to the right of the Sun and a little lower. So they're all in sort of a straight line, so the Sun is between the Earth and these two planets in March. I don't expect you'll see Jupiter or Neptune. And so that is what's up in the night sky for March. Now remember, we don't charge money for this show, but we may tax your brain.